Hello, my dear students. Welcome to Sankalp Learning Classes. ಇವತ್ತು ನಾವು ಕಾರ್ಬನ್ ಅಂಡ್ ಇಟ್ಸ್ ಕಂಪೌಂಡ್ಸ್ ಈ ಒಂದು ಚಾಪ್ಟರ್ ಮೇಲೆ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ ಅನ್ನ ಸಾಲ್ವ್ ಮಾಡ್ಲಿಕ್ಕಿದ್ದೇವೆ. ಎಸ್, so we have already solved the 1 mark question and 2 mark question in the last video. Please go through that video. Okay, so in this video we are going to solve the 3 marks and 4 mark questions specially, and these all questions, they are from old question paper as well as from the model question paper. So these all are very important for your exam. Yes, let us start with the first question. Given below an incomplete equation that represent a chemical process of converting an unsaturated carbon compound to a saturated carbon compound. Complete the equation. Name the gas X and substance Y. And what happens if the end products of this reaction react with chlorine in the presence of sunlight? Here, complete the equation. So here, the equation will be like this. Unsaturated to saturated hydrocarbons will be produced. H, 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 and here also H, H, and the H. Okay, so name the gas X. Here hydrogen gas is released. Hydrogen gas. Then the Y substance, that is the nickel. Okay, Y is the nickel. Then what happens if the end products of this reaction react with chlorine in the presence of sunlight? Here, in the presence of sunlight, C2H6 plus chlorine. In the presence of sunlight, it forms the C2H5Cl. C2H5Cl. Okay, here C2H6, when it reacts with the chlorine, chloroethane is formed. Okay, chloroethane is the product formed when it is reacted with the in the presence of sunlight. Next question. How micelles are formed during the cleansing action of soap? Which are the salts responsible for hardness of water, and detergents are effective even in hard water? Why? This is the question here. How micelles are formed during the cleansing action of soap? Most dirt is oily in nature. Oil does not dissolve in water. So that you know, the molecules of soap are sodium or potassium salts, long chain carboxylic acids. The ionic end of soap interacts with water while the carbon chain interacts with the oil. The soap molecules thus form the structure called micelles. So the micelles are formed like this, where one end of the molecule is towards the oil droplet while the ionic end faces the outside. This forms an emulsion in water. The soap micelle thus helps in pulling out the dirt in water, and we can wash our clothes clean. So that is the answer. How the micelles are forming during the cleansing action of the soap. That is the first one. Second one, what are the salts responsible for hardness of the water? That is calcium and magnesium. Calcium and magnesium salts are responsible for hardness of the water. Detergents are effective even in hard water. Why? Why detergents are effective even in the hard water? Because detergents are more suitable for cleansing clothes in hard water also, because they do not form the insoluble precipitates with the calcium and the magnesium ions present in the hard water. Unlike soaps which would react with these ions and lose their cleansing ability, making the detergents more effective even in a hard water condition. So the detergents are more effective in hard water. So that is the reason. Next question. Carbon could not form C4 plus or C4 minus ions. Why? Here, write the electron dot structure of methane. Okay. Yes, the first one is carbon do not form C4 plus cations and C4 minus anions because it would require lot of energy to remove or add the 4 electrons to the carbon atom. Then C4 plus cation removing the 4 electrons from a carbon atom would leave the cation with 6 protons and 2 electrons, making it highly unstable. So this position is highly unstable. So C4 minus anion, a carbon atom's nucleus with 6 protons, would not be able to hold 10 electrons. Here it is not able to hold the 10 electrons. That is the reason. Then write the electron dot structure of the methane. So this first question is very important repeatedly. So it is asked in many question paper. Okay. Write the electron dot structure of methane. Here. Yes, this is the electron dot structure of methane. Please write down the answer. Electron dot structure of methane. Next question. Identify the unsaturated hydrocarbons in the following carbon compounds and write their structural formula. Unsaturated hydrocarbons. Here, saturated hydrocarbons, they are having the single bonds in between the carbon atoms, but unsaturated hydrocarbons, they have the double or triple bonds in between, at least one double bonds or triple bonds in between the hydrocarbons. Here C6H6, that is the benzene. C6H6 is the benzene, and this benzene that is having the double bond, so we can say that is the unsaturated hydrocarbon. And C5H12, so 1 2 3 4 5, C5H12, so 1 2 3 4 5 6 7 8 9 10 11 12. Here C5H12, that is the C5H12, that is the saturated hydrocarbon. Okay, so this is not a correct one. Next one, C2H5OH. C2H5, 1 2 3 4 5, here OH group. So this is also a unsaturated hydrocarbon. Then check the last one, C2H2, 1 2 H hydrogen 1, here hydrogen 1, C2H2. So here I have to fulfill the carbon atoms, 1 2 3 4 carbon, 4 bonds are there. So this is the carbon-carbon triple bond unsaturated hydrocarbon. So you have to write the structure. C2H2 already you have drawn, C2H1 2, here 1 2, 3 bonds, that is the C2H2. Then carbon 1, 2, 3, 4, 5, 6 carbon atoms and hydrogen bonds. Hydrogen. So here carbon carbon double bond. So this is the benzene. So these two are the unsaturated hydrocarbons and their structure. Okay. Next question. The general formula of cycloalkane is CnH2n and its first member of cyclopropane, that is C3H6. Write the molecular formula and structural arrangement of the fourth member of this homologous series. Here, the first member is C3H6, okay, and CnH2n is the formula. Second member, that is C4H8. Third member, that is C5H10, and fourth member, that is C6H12. Okay, the fourth member is third member, that is C5H10, and the fourth member C6H12. C6H12 is the fourth member. Then structural arrangement of fourth member of this homologous series. So here cyclopropane. So C6 means 1, 2, 3, 4. First carbon, 2 and 3. Carbon atoms and hydrogen, 2 for each hydrogen. Cyclohexane it is. H, H here also, H, H, hydrogen here also, H, H. Okay, so this is the cyclohexane. C6H12 is the structural arrangement of this C6H12. Okay. Next question. Explain how soap clean clothes. More amount of soap is required to clean the clothes in hard water. Why? Please note down the question properly. Explain how soaps cleans the clothes. More amount of soap is required to clean the clothes in hard water. Why? Here, soap cleans clothes by forming tiny structure called micelles that trap dirt and grease, allowing them to be rinsed away. However, in hard water, the calcium and magnesium ions present react with the soap molecules, creating insoluble precipitate that reduces the cleaning power and requiring more soap to achieve the same level of the cleanness. And here, how the soaps are able to clean the clothes. So they form the micelles around the dirt or any grease materials and allowing them to be rinsed away. However, in a hard water, so these ions, especially magnesium and calcium ions will be there. So that ions, they form the insoluble precipitate. Okay. Next question. What are micelles? What is covalent bond? Write any two characters of covalent compounds. What are micelles? What is covalent bond? And write any two characteristics of covalent compounds. Please note down the question. Very important for the board exam. When the cluster of molecules are formed, then hydrophobic tail comes at the interior of the cluster and the ionic end comes at the surface of the cluster, and this formation is called as a micelle. Okay, so that is what the micelle is. Please note down the answer. What is covalent bond? A covalent bond is a chemical bond that occurs between atoms share electrons to form a electron pairs. Covalently bonded molecules are seen to have strong bonds within the molecule, but intermolecular forces are weak. Here, characteristics of the covalent compounds. Okay. So next, the characteristics of covalent compounds, that is, covalently bonded molecules are seen to have strong bonds within the molecule, but intermolecular forces are weak. This gives rise to the low melting point and boiling points of these compounds. Then, since the electrons are shared between atoms and no charged particles are formed, such covalent compounds are generally poor conductors of electricity. So, the covalent compounds are poor conductors of electricity. That is the answer. Next question. How would you name the following compounds? Here, the first one is CH3, CH2, Br. And second one here, C, H and H, here double bond O. And here 1, 2, 3, 4, 5, 6 carbon atoms are there. Here triple bond is there. So it is a alkyne. Okay. Here the first one, 2 carbon atoms are there. So it is ethane. Bromine is added here. So we can write bromoethane. The first one is bromoethane. The second one is here only one carbon is there, but C double bond OH means here that is the methanoic acid. We can say that methane. Next one here, total 1, 2, 3, 4, 5, 6 carbon atoms, triple bond is there. So it is the hexane. Hexane. Okay, sorry, hexane. The correct answer is hexane. Next question. What is hydrogenation? What is its industrial application? What is hydrogenation and what is its industrial application? Please note down the question. Here, hydrogenation is a reaction between the hydrogen and other compounds in the presence of desired catalyst. Hydrogenation is used for reducing saturated hydrocarbons. Hydrogenation is an addition reaction. So, for example, when ethane is heated with the catalyst nickel, it is reduced to the ethane. Okay. Ethene is heated, not ethane. Ethene is heated, it will become ethane. So here, what are the application? In the petrochemical industry, hydrogenation is used to convert the alkenes to alkanes. and cycloalkanes. It is also used to prepare vegetable cooking fat from vegetable oils. Okay. Next, we are going to solve the 4-mark questions. Okay. Very important for your board exam. So, 4-mark questions. Explain substitution reaction with hydrocarbons with example. Explain the mechanism of cleaning action of soap. So this is the repeated question. Yes, the first one. Here, saturated hydrocarbons. Okay, so it is saturated. Saturated hydrocarbons are fairly unreactive and are inert in the presence of most reagents. However, in the presence of sunlight, chlorine is added to the hydrocarbons in a very fast reaction. Chlorine can replace the hydrogen atoms one by one. It is called substitution reaction because one type of atom or group of atoms takes the place of another. A number of products are usually formed with the higher homologous alkanes. A number of products, so usually they are with the higher homologous alkanes. That is the answer. And yes, this is the reaction in the presence of sunlight. Okay, so when the methane that is heated in the presence of chlorine, that forms the chloromethane, and hydrochloric acid HCl is produced. CH3Cl and HCl is produced. Then soap cleans clothes by forming tiny structures called micelles that trap dirt and grease, allowing them to be rinsed away. However, in hard water, the calcium and magnesium ions present react with the soap molecules, creating the insoluble precipitate that reduces the cleaning power, requiring more soap to achieve the same level of cleanliness. Okay, yes, that is the answer. Next question. Carbon atoms do not form CO minus anions and cations. Why? So already we have seen the answer for this question. And write the electron dot structure of nitrogen molecule and the ethene molecule. Yes, what is the answer for the first question? That already we have seen in the last 3-mark question. Yes, so this is the electron dot structure of ethane. Okay, so nitrogen you have to try yourself. Try to write the electron dot structure of nitrogen. Okay, very important for your exam. Next question. If the molecular formula of first member of homologous series is C2H2, then write the names and molecular formula of the next two members of the same series. Here C2H2, that is CnH2n minus 2, C2H2 into 2, 4 minus 2, that is H2. Yes, CnH2n minus 2 is the formula. Here C3H 6 minus 2, CnH2n minus 2. Here 6 minus 2, C3H4. CnH2n, so that is not the formula. CnH2n plus 2, that is not applicable. CnH2n minus 1 is next two members. So like that, C2H2. So here CnH2n minus 2 is the formula. Okay. 2 into 2, 4. 4 minus 2, 2. Next one, C3H3 into 2 minus 2. 6 minus 2, 4. C3H4 is the next one. Then C4H 8 minus 4 to the 8 minus 2. C4H6. Generally, vegetable oils are subjected to hydrogenation. Why? What is the reason behind this? Vegetable oils are hydrogenated to make them more stable, extend their shelf life, and change their physical properties. So that is the reason. Next question. Write the structures for following carbon compounds. First one, cyclohexane and propanoic acid. Cyclohexane, so that is C6H12. So here we have to write the cyclohexane structure. Total 6 carbon atoms. 1, 2, 3, 4, 5, 6 carbon atoms and hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so C6H12. Write any two differences between saturated and unsaturated carbon compounds. Write any two differences between saturated and unsaturated carbon compounds. Here, sorry, one more thing, that is the propanoic acid. Here, propanoic acid, that is having the CH3, CH2, COOH, right? Propanoic acid, CH3, CH2, COOH, that is the propanoic acid. So the structure is, so C, that is having the 3 carbon atoms, H3, 1, 2, 3, and second carbon atom, H, H, and here third carbon atom, double bond O, OH. Next question. Write any two differences between saturated and unsaturated carbon compounds. Here I'm not giving the answer for this question because already in the last video, in the 1 to 2 mark question discussion, we have discussed the difference between the saturated and unsaturated compounds, the differences. So please go through that video. Okay. Next one, write the electron dot structure of oxygen molecule, and again same repeated question. So just see the question how many times it is repeated. Okay. B, write the electron dot structure of oxygen molecule and carbon atoms does not form the C4 minus anions and C4 plus cations. Why? Okay, that is the reason. This is the answer for the next question. What are structural isomers? Write the molecular and structural formula of butane. Then what is catenation? Write the general formula for alkene. So this is also 4-mark question. The first question is, what are structural isomers? Compounds with identical molecular formula but different structures are called structural isomers. Here butane structural isomers of butane, a molecular and structural formula of butane. Here the butane formula, molecular formula is C4H10. Okay, so it shows the isomerism here. 1, 2, 3, 4 carbon atoms and hydrogen atoms that fulfill the carbon valency. So total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen atoms, and here 2 carbon atoms, and which is attached like this. So this is also same C4H10 only, but that arrangement is different. Okay, so these both the diagrams you have to practice. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen atoms and 4 carbon atoms arranged like this. Both are same, but their arrangement is different. That is the difference. Okay. Next question here. What is catenation? Write the general formula for alkenes. What is catenation? Write the general formula for alkenes. Here, what is catenation? Catenation is the self-linking of atoms by an element to create the chain and rings. Catenation is the self-linking of atoms of an element to create the chains and the rings. Here, write the general formula for alkenes. The general formula for alkenes, that is CnH2n. That is the general formula for the alkenes. Next question. Write the differences between saturated and unsaturated hydrocarbons. Write the molecular formula and structural formula of an alkene having the 5 carbon atoms. Yes, here we know the difference between the saturated and unsaturated hydrocarbons. So this is the most repeated question. And second one, we are going to solve the second question. Write the molecular formula and structural formula of an alkene having the 5 carbon atoms. Here, 5 carbon atoms. 1, 2, 3, 4, 5. You know the general formula of alkenes, that is CnH2n, means C5H10 is the, that is the pentene. So here 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Here double bond I will add. Just a minute. So here I will add the double bond here. So 1, 2, 3, 4. 4 carbon compounds are carbon valence is fulfilled. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total hydrogen bonds. Okay, so this is the pentene. 5 carbon. Yeah, this is the answer. So again, same question. Carbon atom does not form the C4- anion and cation. Why? How can ethanol be converted into ethanoic acid? Ethanol, that is the alcohol, and how can be converted into ethanoic acid? Here, when the ethanol that is treated with the alkaline KMnO4 or acidified potassium dichromate and heated, the ethanoic acid is formed. Ethanol, that is CH3, CH2, OH group is there, that is the ethanol. And when it is heated with alkaline KMnO4, the oxidizing agents, so these are the oxidizing agents, or acidified potassium dichromate, it forms the ethanoic acid. Please write the word. Okay, so please write the answer in words. So here I had given the equation, but along with the equation, please write it in the definition. Okay, how? So they asked here, how can ethanol be converted into ethanoic acid? So you have to write it in words. Okay. Yes, when the potassium permanganate, so when react with the ethanol or alkaline potassium dichromate, so it forms the ethanoic acid. Next question. What are structural isomers? Write two structures of butane molecule. How would you distinguish experimentally between an alcohol and the carboxylic acid? What are structural isomers? We know the answer for that, and write the two structures of butane molecule. That is already we have solved in 2 mark, 3 mark questions also, and in this video also we have solved that. So we are going to solve the next question. How would you distinguish experimentally between an alcohol and the carboxylic acid? Here, to experimentally distinguish between the alcohol and the carboxylic acid, the most reliable method is to perform a sodium bicarbonate test where the carboxylic acid will readily react with sodium bicarbonate, producing visible bubbles of carbon dioxide gas. While an alcohol will show no reaction, you can also use the litmus test, where the carboxylic acid will turn blue, litmus paper red, while an alcohol will not change the color of the litmus paper. Okay. So that alcohol will not change the color of the litmus paper. So that is the answer. Yes, esters are most commonly formed by the reaction of acid and the alcohol. Next. Explain the addition and substitution reaction with the help of examples. C2H6 undergoes the substitution reaction but not the addition reaction. Why? Okay. Here, explain the addition and substitution reaction. The first one is unsaturated hydrocarbons add hydrogen in the presence of catalysts such as palladium or nickel to give the saturated hydrocarbons. Catalysts like substances that cause the reaction to occur to proceed at a different rate without reaction itself being affected. This reaction is commonly used in the hydrogenation of vegetable oils using the nickel catalyst. Vegetable oils generally have the long unsaturated carbon chains while animal fats have saturated carbon chains. Here, so this is the example how unsaturated hydrocarbons are converted into saturated hydrocarbons. And substitution reaction. Saturated hydrocarbons are fairly unreactive or inert in the presence of most reagents. However, in the presence of sunlight, chlorine is added to the hydrocarbons in a very fast reaction. Chlorine can replace the hydrogen atoms one by one. It is called substitution reaction because one type of atom or a group of atoms takes place of another. A number of products are usually formed with the higher homologous alkanes. So here C2H6 that will not undergo the substitution reaction, which undergoes the substitution but not the addition, because C2H6 that is the saturated hydrocarbon, meaning it is already has the maximum number of hydrogen atoms it can hold, so it cannot add more atoms to its structure. Next question. Name the following compounds. Here, 1, 2, 3 carbon atom is there and C double bond OH means it is CH3, CH2, COOH. It is ethane propanoic acid. It is propanoic acid. Propanoic acid. Then here 1, 2, 3, 4 carbon atoms are there. Here double bond is there. Right. So we can 1, 2, 3, 4, 5, 6, 7, 8. C4H8, that is the butene. Here, this is the alkene. Butene, we can call it as the butene. Then here 1, 2, only 2 carbon atoms are there. So methane, ethanol. So because OH group is there, so it is the ethanol. Ethanol. Then here 1, 2, 3, 4, 5 carbon atoms are there and triple bond is there. So it is the pentyne. It is the pentyne. Okay. So let us check this. Butene, propanoic acid, and it is the ethanol. Propanol means 3 carbon atoms should be there. So this is the ethanol. Okay. CH3, CH2OH. Next question. What are saturated carbon compounds? Define the following. Esters and homologous series. What are saturated carbon compounds? Define the following. So here saturated hydrocarbon compounds means they have the single bond between the carbon-carbon atom. So they are called as saturated carbon compounds. Define the following. Esters and homologous series. Esters are organic compounds that are formed when an acid and an alcohol combine and water is removed. Compounds in which the same functional group substitutes for hydrogen in a carbon chain is called the homologous series. Please note down the answer. We know the definition of saturated hydrocarbon and esters, and you have to write the homologous series. Next question. Draw the structures for the following compounds. First one, you have to write the ethanoic acid. Ethanoic acid means 2 CH3COOH. Here, the structure is CH3COOH. Okay. The first one is the ethanoic acid. Then second one, bromopentane. Pentane means 5 carbon atoms will be there. So bromine group is attached. So one hydrogen group, so that is attached by the bromine group. Okay. Here C5H12 is not there. C5H11Br. So second one is the bromopentane. Third one is the butanone. Butanone, that is the, yes, CH3, here CH2, C double bond O is there, here CH3. Here butanone, ketone group is present, so it is the butanone. The last one, that is hexanol. Hexanol means, hexane means 6 carbon atoms will be there. Hex, Al is there means hexanol, that is the CHO group is there. Aldehyde group is present, C double bond OH. Aldehyde group is attached to the last carbon atom or the first carbon atom. So that is called as a hexanal. Okay. So yes, these are the structures of ethanoic acid, bromopentane, butanone and the hexanol. Please practice these structures. That is very helpful for your exam. Yes, Dear students, I will stop the class here. So in this video, you will get the 3-mark important questions and 4-mark important questions along with the answer. And it is very helpful for your board exam preparation. Thank you.